before proto danksharding, it's like every node stores the data forever. Now we're going to like every node stores data for some amount of time. And then full danksharding would be every node stores some data for some amount of time. And then you have cryptographic proofs that tell you that other nodes are actually storing the whole thing. And so L2s can obviously rely on it without the fear that like their blob was somehow excluded from the chain.
On this episode, we talk with Tim Beiko, who runs the Ethereum All-Core Devs calls. Kevin, I'm curious what you took away from this convo.
Yeah, this is great. We got to compare our episode with Hudson, where he was previously running All-Core Devs, and Tim gave kind of a unique perspective on it. We talked a little bit about what will be involved in the Denkun upgrade and what the time frame is currently for that, making its way to mainnet. We talked about sort of some of the stuff that he's excited for that's coming after that in probably the next hard fork. And yeah, I don't know. Tim's super awesome, easy to talk to, very good at taking complicated ideas and creating easy analogies for it. So very good episode.
Totally. We talked a ton about upcoming upgrades and the actual process for how these things happen. So I learned a lot, and hopefully you all enjoyed the episode as much as we enjoyed recording it. We are here with Tim Beiko. Tim, super excited to have you on the pod.
Thank you both for having me.
GM Tim, thank you for coming.
Tim, you do a lot in the Ethereum ecosystem, including running the Ethereum All-Core Dev calls. Maybe we can start off with how the hell you ended up running them. You know, we had Hudson on the podcast a couple episodes ago, and so it's kind of fun to see you come on next, sort of taking over that role. So maybe you can give a little bit of context on how you got where you are today.
Sure, of course. So very short version is I took over from Hudson. But maybe to flesh this out a bit more, I followed Ethereum since about the launch. I knew about Bitcoin before Ethereum existed. And when right around Ethereum launch, I think I heard about it, but I didn't pay too much attention. And then the thing that got me paying attention to Ethereum was the DAO before the hack. So I sort of got into Ethereum when I heard about the DAO because it finally seemed like there was a use case where Ethereum was building something you like could not do on any other blockchain, right? And for the listeners who might not know, the DAO was basically a VC fund based on Ethereum. So it was the first DAO that was deployed. And the idea was you would pool all the money together, and then your money in the DAO would give you governance vote around like which projects the DAO would invest in. But the thing that happened is the DAO raised about 15% of all the ETH that existed and got hacked right after that. And so there was this big debate in the Ethereum community. How do you deal with the hack? Do you make a regular change to the protocol in order to make all the victims of the hack and people who lost their funds whole? Or should you just leave the hack be and treat the chain as actually immutable? And I had no idea what any of that stuff meant. I literally just bought tokens online and, wanted to invest in this like crypto VC fund. So it was really like the thing that pulled me in the deep end real quick. And after the DAO sort of hack happened, the chain fork, there was the split with Ethereum Classic. And there was maybe like a 6-month period where Ethereum seemed pretty dead. And where, at least from my perspective, I was sort of thinking, well, if we have this smart contract platforms, but you can't write smart contracts without getting hacked, is that actually a useful thing to have in the world? Like, are we going to actually see smart contracts being used? So I paid a bit less attention, but then about 6 months after that, this was like late 2016, you started to see some projects launching on Ethereum again. And by 2017, there was this huge round of ICOs, and it was clear that there was, pretty significant demand for Ethereum as a protocol. And at that point, I wasn't necessarily super confident in any of the individual projects being built on Ethereum, but it felt pretty clear that like Ethereum itself would probably stick around. And just as a user, trying to run a node, trying to like do stuff on chain, the experience was pretty terrible. And so that made me want to work on making the protocol itself better, because this was a way to like, make the whole sort of foundational infrastructure good. And, maybe the apps today would all fail, but then for sure there would be apps at some point that would end up working, and you'd want to have a protocol that was suitable for them then. but it was kind of a weird thing to start working on. I was a product manager at the time, so I wanted to like be a product manager on something that was not a product because Ethereum's like a protocol. And I got lucky that Consensus eventually started a protocol team and sort of set it up like you would a typical tech startup. So they had product managers there. And that's how I started working on Ethereum full time. I joined Consensus's protocol team as a product manager. So I worked on Hyperledger Besu there, the execution client, and spent about 2.5 years working on that. And as part of that, I sort of started joining the All Core Devs calls, which Hudson ran at the time. And aside from Hudson, for a long time, I was the only like non-engineer or researcher on the call. So I just started helping up with, random project management stuff around All Core Devs. And then by 2020, Hudson had been doing this for like 5 years already and wanted to move on. And I was sort of the only person who'd been on the call for a couple of years, had like a fair amount of context about the protocol, about building a client, but also wasn't an engineer. So it sort of worked out naturally for me to take over. And so, at late 2020, I sort of moved to the EF and gradually took over a couple months while Hudson sort of phased out. And I've been at the EF pretty much full time since 2021.
Super cool. Yeah, I like the through line of the episodes where every time someone's like, hey, this looks interesting, I wonder what I'm going to do. The people that just decide to like jump in and get their hands dirty often find themselves doing like the most interesting stuff. And I think this is like a perfect example of that. You saw kind of a need in the All Core Devs call to help herd the cats, and then you kind of ran with it and ended up doing that full time. Yeah, when we chat with Hudson, we got to hear a little bit of his perspective of sort of like what it's like to be the IRL consensus builder. Curious to hear your perspective on what that's like, just the kind of ins and outs of running that actual conversation, and sort of like what your experience has been for as long as you've been running it, which is how long?
How long? So I started doing this like early 2021. So like,
Okay.
I guess 3 years at this point.
Cool. Yeah. What's your experience been?
It's definitely a very unique forum. I think the way I used to evaluate myself or think about like, am I doing this right or wrong, was can we get to like the root disagreement as quickly as possible? I think historically, when we've done things poorly on All Core Devs, it's when we spend like a long time debating something, but somebody has like a more fundamental objection. And so we're like, debating some like high level details, but there's some deeper reason why the thing is either going to work or not work. And we haven't quite reached agreement there. So I'd say like the most explicit amount of design I put into like how the calls run or what we talk about is really around this. Like, what's the biggest decision we have to make? Who are the people who have like the strongest opinion or are able to articulate the strongest opinion on both sides? And can we get like those people to come on, hash it out, and then, come to a decision or a next step? That's really like the main core thing. Beyond that, like just not wasting a bunch of time debating, random technical details. I think we've really improved the overall like engineering quality of the process in the past 4 or 5 years. And this is not like something I want to take credit for. And I think Danny, who runs the CL call, has done a great job sort of instilling that culture on the proof of stake side. And with the merge and all of that, it sort of bled in on our way. But then, the EF hired like more DevOps people, more testing people. But I think the overall like quality bar of engineering that we have now is just super high. And what this means is, I remember like some of the first forks I worked on when Hudson was running the call, it would take us a huge amount of time to test things that were relatively trivial changes to the EVM. And now we're in a spot where like we have these huge upgrades. Like we had 1559, we had the merge, we have the blobs coming up. And those are upgrades that sort of, they change like the shape of the protocol. They don't just like add a little opcode or, change like a value. 1559 made the block size variable. And the merge was obviously this massive change to the consensus mechanism. Now with the blobs, we're adding this whole new like data field to the network that needs to be gossiped and whatnot. And the fact that we're able to do these changes that are like much, much bigger and more ambitious is like a really big addition that we didn't have before. So that's one thing that like, I don't want to take credit for this. Like it's a bunch of people's works, but I think overall, All Core Devs has gotten much, much stronger on. So yeah, I feel like if we can get those two things right, and that's the bulk of it, And I'd say the other bits that we've spent time thinking about is just how do we make the, for lack of a better word, like community or the like maintainership group like better. And then luckily now at the EF, I have a whole team that works with me. Hudson was like completely alone when he worked at the EF. And now we have a team called Protocol Support. So we get a bunch of people to help with this. But we've done things like, for example, the Ethereum Protocol Fellowship. So we have this, you can think of it as like a core dev internship program where we get a bunch of random people, assign them to work on protocol stuff, and then have core devs, work with them to like onboard them. And they're not necessarily junior in that they're like young engineers with little experience, but they just haven't worked with the protocol yet. And that's been like a really good way to sort of formalize the pipeline around how do we get people to come and contribute to this, because it's not an easy thing to just show up and work on. Another thing, this is again like much broader than just me or the EF, but Protocol Guild was another initiative we started around how do we get projects who want to fund core development and help like maintain a strong set of core devs to do that in the best way. So we have Trent on our team who's worked on that, and now a bunch of other like core contributors to Protocol Guild putting that together. And so all these things around just like the community of core development, I think is something where, yeah, we've spent a lot of time and energy in the past couple of years, and I think it's also made things better.
Yeah. I'm curious, you mentioned like blobs and 4844 and proto dank sharding and sort of that specific thing. When you talk about like some of the most interesting other implementations that you think are most important to bring to the table and talk through, what comes to mind?
So, I mean, we have the stuff that we're doing now. So, like the biggest one, like you mentioned, is blobs. So, allowing ephemeral data for L2s, that's a huge one. And blobs are kind of, or the version of blobs we're shipping in the next couple of months is basically the first step. But we're going to keep sort of improving the amount of data that we can have on the network, and that'll be quite valuable for L2s. So, that's a huge just branch of research that's been worked on for years, and it will keep going into the future. I think the other big one in terms of scaling is everything to do around statelessness. And the idea there is that Ethereum, we literally use the word state, but if you take like the list of all of the accounts, all the smart contracts, what's in the accounts, what's in the smart contracts, everybody's ERC20 balances, the NFTs, the Uniswap pools, all that stuff at a single point in time is called the state. And before, when people talk about like blockchain scaling problems, they usually talk about like the history. When people say like an Ethereum node is like super hard to run, they would tend to talk about like, if I want to look at my ERC20 balance like from a year ago, that would be like super hard. And we've done a bunch of work on making that easier. But as Ethereum gets adopted, even looking at like the current state of things, like I want to see everybody's ERC20s right now, is becoming a more and more challenging thing. And so we have a lot of architectural work that's hoping to bring us towards a step where users don't need to care about like the full state, where you're able to say, oh, this is like the subset of the state I care about, just my own accounts or the accounts I'm interacting with, and I can verify that they're correct. So for example, if you're receiving funds from somebody, verify that they actually have the funds in the accounts that they're sending the funds to you from, and those things. So where we call this like stateless clients in general, but this whole idea of moving from everybody has to have a full copy of like everything that's on Ethereum to we can divide this and allow people to only query and gossip the part that they care about. That's a huge, huge piece of it as well. And then obviously, Vitalik has like his entire like roadmap with all the different things. But I'd say, in the next couple of years, just like scaling the data on the consensus layer and then moving to a spot where we don't need the full state on the execution layer are probably the two biggest overhauls that we're working on. Yeah.
I know Vitalik updated his image of the roadmap maybe about a month ago. How far down the roadmap is something like stateless clients, and how much of the conversation are you focusing the all core devs call on like what's happening right now in this section of the roadmap versus like let's start to talk about planning ahead?
Yeah, great question. So the biggest component to stateless clients is, if you imagine we each have a little part of the state. I have my account, you have yours. The state is stored in a tree that kind of looks like a Christmas tree. So it's like very tall and narrow. And if you want to send a part, you have to send something that's at the bottom of the tree. So we call these witnesses, these part of the states, they're like super big because they have to go from the top of the Christmas tree all the way to the bottom. And so doing this is impractical because you just have to gossip these huge things on the network. And then at that point, it's just better for everybody to have a local copy. So the first thing we need to do to move to the stateless world is to sort of change the type of tree we use to store everybody's data. And this is what we're moving to, something called a Verkle tree. And this is, if you've heard of Verkle trees, this is what it means. You can think of a Verkle tree as something that looks a bit more like a bush, which is like super long and not super high. It's not quite a bush, but bear with me here. And so if you're sending a witness from a Verkle tree, then it's a much smaller bit, going from like the top to the bottom to the bush versus the Christmas tree. And that allows you to gossip them at scale on the network. So this is the biggest change to the protocol we need to do, is we need to freeze the current Merkle tree we have at some point, say like, okay, this is a tree at point X, reconstruct this, like translate this tree to a Verkle tree, so copy over all of the data, and then start modifying stuff in the new tree. And as you both know, Ethereum doesn't go down. So these upgrades are very hard for this reason. Like if we could just, shut Ethereum off for a weekend, this would be trivial. It's like, okay, Friday night, we have the Christmas tree and we wake up Monday morning, we have the bush and we've just like migrated everything over the weekend. The challenge is we just can't do that. So similarly to the merge, we have all this work that has to happen to figure out, okay, can we do most of this in the background so that at some point, it just activates on a hard fork and the conversions already happen and you smoothly go from one to the other. So this transition is something that people have started working on. So there are a bunch of prototypes of it. There's a website called verkle.info that lists like all the current prototypes and where things are at. And I think in the next year, this will become one of the main things that, at least on the execution layer, we start working on. So there's still debate right now around whether this should be the next fork right after the blobs or maybe the one after that. But regardless, people are going to start working on it. And then there's a question of just how quickly can we ship this? But that's really the biggest piece of work. Once we've done the tree transition, everything else pretty much can be implemented without a hard fork. So you could imagine clients just starting to offer like a stateless mode and, having like a beta version of that, seeing if it works and whatnot, and like getting user data. And it looks a bit more like normal product development at that point, whereas doing the actual tree transition requires a ton of coordination and it has to happen all at once. Yeah.
And then just like an order of magnitude estimation, what would the difference be for someone who wants to spin up a client in stateless mode? What's the maybe hardware requirements for something like that?
So you could imagine the storage going to like almost zero in a world where like you don't need anything except a couple accounts. But the other thing that you could imagine as well is even something trusted, like say you're using MetaMask, which by default uses Infura, they could send you signed proofs of like the state, right? Like, so it becomes cheap enough that as an end user, you can verify the same way you verify a signature or something like that. Or, like when you use HTTPS, right? Like you verify all these signatures, it becomes small enough that like it can be gossiped at that scale. So if you want to keep just, a copy of a small part of the state, on like a normal computer, then that's totally fine. And then, we'll see what clients come up with, but there is, theoretically, it's like you can tune this to the level of granularity that you want. And you could only care about 5 accounts, which have a proof that's like a couple hundred kilobytes each. And it's like 1 meg total. And then you can know that when you send a transaction, these accounts are the ones you own. Then you send that proof alongside it. And once the transaction is executed, you update your account storage and that's it. So yeah, it really opens up like a whole new design space.
Yeah, that's awesome. Yeah, I'm excited for what that means in terms of being able to run proofs on your phone, or effectively like for a web 2 application to be able to not have to run their own or like pay for their own entire instance of Ethereum to do this like one thing that their app needs to do.
Right. And this is the thing an app could do as well, right? Like imagine your Uniswap, that like this account has these pools. You could imagine like a local copy of that even being stored in like my browser, right? So you can have like the app level granularity and then do that on like their users' behalf as well. Yeah.
I think one problem I always struggle with in this space is that all of the problems being worked on feel like fun, interesting rabbit holes. Now, you as sort of like helping to organize the conversation, before you is a set of 10 different nerd snipes, and you have to like focus the group in on what you consider to be like the most important one? How do you go about doing that?
So I guess I don't really get to choose what I think is the most important one, right? So we definitely have to come to that. In practice, so the best model I've come up with to think about how Ethereum hard forks are planned is like a music festival. So if you think of like a music festival, there's usually one or two headliners and then a bunch of like support acts. If the headliner has to like delay, they'll probably move the entire show. But if like the seventh random band has to delay, they'll probably just have the show without the, first opener or something like that. And so I think in practice, what we end up doing looks a bit similar, where there are these big things like, say, Vertical trees or, the blobs in the fork that we're working on now. They end up being a sort of headliner in a way. And the way we come to consensus on the headliner is usually a mix of like urgency and readiness, where some of these things just aren't in a spot where like client developers can actually implement them and do something useful with it. Like if you look at, say, Vitalik's roadmap, like the stuff that's on like the right part is like, it's not bottlenecked by 10 different client teams working on it. It's bottlenecked by like 5 researchers working on it and then coming up with a prototype and whatnot. And so these larger efforts sort of develop over often like years, and they reach a point where it's like, okay, there's like, a bunch of researchers, maybe a couple client teams already looking at this, and we're pretty confident on the overall design. And, we're ready to move this and make this the main thing for everyone. It's a bit rare that there's like that many of those big things that come up at the same time. In practice, there might be like 1 to 3 rather than 10. And I think there it's like, yeah, it's a question of like people prioritizing and deciding the sort of risk versus reward, like ROI of the thing, like how big is it versus how valuable it is. And then usually once we set that in, you can kind of come to agreement on a bunch of smaller things, right? So like in this hard fork, for example, we have obviously EIP 4844. This is a huge thing, but there's like 3 or 4 different other EIPs that make changes to the EVM that were all relatively simple. And those are much easier to just come to consensus on once like, okay, we're doing blobs and like how much extra room do we have left? Yeah. So if we can align on like the biggest thing, usually the smaller thing is not a huge deal. And if something small ends up becoming like a much bigger deal than we thought, then we can just push it back to the next fork for whatever reason.
Yeah, I love the band analogy with headliners. That's really funny. You mentioned blobs a few times. I kind of want to talk a little bit more about 4844 and like what that actually entails and means, and maybe even how we got to this point. L2s feel like they've been having a moment for the last year, and so I think this is really exciting for that community and continuing the momentum there. What the hell are blobs for people who have not been following this? What is the change happening?
Great question. So to zoom out a little bit, on Ethereum, you have a single chain which processes every single transaction. And when we say the chain processes every transaction, it means every single node on the Ethereum network processes the transaction. We use the word validator to talk about like the stakers on the network, but it's kind of a weird word to use because even a non-staking node validates every single transaction it sees. And because of this, it's super secure, but the downside is it's expensive, right? There's only so many transactions that every computer running on Ethereum can validate per unit of time. So we cap it with the gas limit, and then it becomes expensive to do that. And so the idea with layer 2s is that you have these separate chains that do not have the layer 1 validate every single transaction, but only in the case of an optimistic rollup, what they do is they send back all the data from those transactions, and then they only run the transaction on L1 if somebody disputes it. So if everybody's running the L2 transaction and they're like, all good, it's fine, nobody has to run it on L1. But if somebody disputes it, then they go back to L1, and this is what they call a fraud proof or a fault proof. And then for ZK rollups, it's a similar idea, but they just send a ZK proof that all the transactions were actually correct. And so if there was an issue with the proof, you could sort of pinpoint the exact proof. And the reasons why rollups are cheaper is because executing computations on Ethereum is cheaper than storing data on it. So it's cheaper for an optimistic rollup to just run all the transactions off chain, take all the transaction data, bundle it, and then put that back on Ethereum, even though they need to pay for all this storage, than it would be for them to run all the transactions. And same thing for ZK rollups, where putting the proofs is cheaper than putting the execution on chain. And then now, this is why rollups are cheaper than L1 today. But rollups don't need this data to be on chain forever. And right now they're basically paying for this. So they're paying the chain to store the data forever. But if you look at an optimistic rollup, usually within 7 days, you can take your funds out. So effectively, as long as the data is there for 7 days, that's really the only time that matters, because if there was an issue for longer than that, the attacker withdrew their money already. And then ZK rollups is an even shorter time period. So the idea with Blobs is that we're introducing data on Ethereum that is ephemeral. So it only stays on the network and saved by all nodes for a period of a couple weeks. And so this is cheaper for rollups to use than the data that gets saved forever, because it gets pruned every, n weeks. And because the data is cheaper to post, transaction costs on rollups are about 90% the cost of posting the data back to L1. So this costs, if we lower this on L1, then we can lower the cost on L2. And so that's the rough idea, is that we go from data that has to be stored forever to data that only has to stick around a few weeks, which doesn't change any of the trust assumptions for L2s, but is cheaper for them to use. Yeah, so I'll pause here. This is what we're shipping with the Blobs right now. And we can talk about how do we scale even past that in the future. But yeah, I'll pause here as a good stopping point.
Yeah, so this is what you're describing is proto-dank sharding is the version that we're going to ship with Denkin. And then it sounded like the sort of next iteration after proto-dank sharding to full dank sharding isn't much more complicated, or at least the majority of the complexity was included in proto-dank sharding, and getting to the next stage might be not a big deal.
Yeah, so maybe the difference between what we're shipping now and then the next stage. The biggest thing that's not going to change from now is the API for L2s to use this. So this was the most important thing with proto-dank sharding, is you can think of the front end as being final, and then L2s are able to plug into this, use the blobs and whatever. And then we're going to do changes in the future to raise the capacity, but L2s are not going to have to do anything to get those changes. They'll just happen for free. More blobs will just show up. And so that was a big part of the work, just laying off the basic scaffolding for this. In terms of just scaling the blobs, one thing you can do is you can increase the number of blobs, but this is akin to increasing the block limit. You do this at the expense of just more storage on every node. So the idea with full dank sharding is, instead of just increasing the number of blobs, is you don't have every node store every single blob. They only store a subset. And so if you imagine there's a certain number of nodes on the network, and each of them store a subset of all the blobs, every blob gets stored, a large number of time on the network, and every node can create a proof that they're actually storing a certain subset of the blobs. And therefore, we have a extremely high probabilistic guarantee that all the blobs are there somewhere on the network, and, in practice multiple times on the network. And so this is basically the next step with proto-dank sharding. It's going from every node. If you think of before proto-dank sharding, it's every node stores the data forever. Now we're going to every node stores data for some amount of time. And then full dank sharding would be every node stores some data for some amount of time. And then you have cryptographic proofs that tell you that other nodes are actually storing the whole thing. And so L2s can obviously rely on it without the fear that their blob was somehow excluded from the chain. And so that'll be also a lot of work. I don't want to diminish it, but in terms of if I'm an L2 using this, you won't see a difference from the time when you needed to query your blob that every node had, to you need to query a blob that, is somewhere in the network. And that's why sort of it was quite valuable to design things the way they are, so that L2s can start using the improvement that's coming right now, but they won't have to do anything else to use the further improvements.
Yeah, I appreciate that high level summary. I think sort of the step-by-step getting to full dank sharding, and sort of the important through line that at each step of the way, we aren't losing any of the security guarantees that we've had kind of from the beginning.
Right. Yeah.
I like that. So I like your analogy about the headliner. So we think of proto-dank sharding as the Denkin headliner. We've still got a little bit of time. I know we just finished the Goerli hard fork, and it sounded like that went pretty well. And then Sepolia, I think, is this week. Is that right?
Yeah, so we're recording January 29th. Sepolia is tomorrow on the 30th. So depending on when this comes out, it might have already happened.
That's awesome.
Yes, hopefully it will have already happen. Also, is it Denkun or Denkin? Or
I say Denkun. I say Denkun, but I don't think there's an official pronunciation. It's already so hard to agree to a name. We can leave the pronunciation open. Yeah.
Sure. I don't even think it's technically Gorley. It's like a word that I'm not pronouncing right.
Yeah.
And then we have Holsky.
Holsky, yeah.
Holsky is February 7th. Is that right?
Yeah, that's correct. So that'll be the last testnet
Cool.
to have the upgrade.
Awesome. And then it's basically, we're like high level Q1 2024 will be mainnet general estimate.
Yeah, so I think once we've seen all 3 testnets fork, which will be more than a week from now, assuming things go well, then we'll be ready to move to mainnet. And then there's one thing we want to see as well beyond the fork, and now Gordy has already upgraded, and I talked about these blobs, the data expires over time. So sometime, if not late this week, early next week, the data from the first blobs on Gordy will start to expire. So that's also something we just want to see happen before we move to mainnet. Yeah. So, but like, yeah, once we've seen all 3 test nets, I think they're stable there, we'll decide on a date for mainnet. And usually by the time we decide, we just give people a couple weeks to upgrade their nodes and whatnot.
I have a stupid question, which is that I feel like for Dencode in particular, I feel especially aware of a number of projects that will be impacted by it, whether it's because of proto-dank sharding with L2s or like some of the flash accounting stuff with Uniswap. Like there's a lot that feels like is sort of made possible by this. Is that typical of an upgrade? Like how often are projects actually sort of like, okay, this is really exciting and actually impacts what we're doing?
Yeah, that's a good question. So I guess the phrase you use is a bit different than impacted, right? Like, so when we think about projects being impacted, you sort of framed it positively. The negative case is like breaking projects. So we try to almost never break projects. And there is this EIP in Dencun that changes how self-destruct works, that now has all these edge cases around it to make sure that important stuff basically did not break. So that's like the main consideration is if we're shipping something, try to not break what exists on chain. In terms of new functionality, yeah, I think we generally try to do stuff that's useful for people and provides new functionality. The risk is always one, the complexity. And the complexity both of the thing itself, but also if the thing interacts with like the big new change that we're doing. That's always like a concern. So for example, when we shipped the merge, the one obvious thing we did not ship was withdrawals for stakers at the same time, even though it was obviously a hugely valuable feature. We decided to put that in the next fork because shipping both the merge and the withdrawals, which impacts proof of stake and the execution layer at the same thing, it just felt like the testing those 2 things in combination became like exponentially more complex. So generally, if we can get like one big thing done, we'll try to think of what are all the other small things that are valuable to people. And then if those things are parallelizable and don't impact the big thing, then that usually allows us to do more of them. And in this fork, we did manage to do a fair amount. So we have the transient storage opcode, which you mentioned that Uniswap helped advocate for. We have another one, mcopy, so a better just memory management opcode for the EVM. We are changing how self-destruct works. We have one as well on the beacon chain side where we're changing the validity for exit messages. So if there's these staking pool constructions where people have to pre-sign exit messages to keep things trustless, those messages will not be valid forever. So we have a bunch of these other changes coming at the same time. And I think, yeah, for those, it's always a question of, can we do them? Like, do we have the bandwidth? And, ideally, are they isolated from the big thing we're doing? And in this case, yeah, there was a lot of stuff we could do.
It's like a positive version of when people try to pass laws in Congress and they're like, oh, we're going to jam all this other stuff into it. But it's a good version.
Right. Yeah. And the thing is, people have like debated whether we should have bigger or smaller forks over and over. And I think because there is like such a high fixed cost to testing and we literally have to get everybody to upgrade their nodes. And this is kind of a weird thing. Like people don't realize this, but it's like the core devs, we have all these teams writing the software. And then the most we can do is like a strongly worded blog post, saying, please upgrade your node. But there's no like on-chain governance. There's no mechanism that like forces people, not even to like upgrade, but even to just pay attention, right? So we do want to be mindful that like every time we upgrade the chain, it is like a risk and a high cost of like coordination. So this means that, yeah, we have to ship upgrades, which combine a bunch of different things. Because if we had a hard fork every month with like a single EAP every time, then it's like, oh, this chunk of validators forgot to upgrade this time. Oh, these exchanges forgot to upgrade this time. And that would be super chaotic. So yeah, we have to bundle stuff.
Totally. Use the attention while you have it.
Yeah, exactly.
You mentioned Protocol Guild earlier. I want to make sure we talk a little bit about it. What is the history of Protocol Guild? I am mostly aware of them because they were most recently in Optimism's Retro PGF. So yeah, maybe you could talk a little bit about that.
Yeah, so the history is funny. So this started with a tweet by Danny Ryan. Someone on Twitter was complaining that all the protocol devs were going to work on DeFi, and Danny answered that all the DeFi devs should just give 1.5% of their tokens to protocol devs, and that the protocol devs were more useful than the VCs to DeFi. And so if you gave them tokens, they might stick around, and it would be valuable for the projects because then there's still smart people working on Ethereum. And so Danny tweeted this randomly one day, and we started talking about this idea a bit more within our team. And we had Trent Van Epps on the team. He'd been involved in like a bunch of projects in the past around just recognizing and rewarding core contributors for stuff. So like he'd done the Beacon book, if you've seen that, but it was like a whole book with a bunch of NFTs, and all the proceeds went to the people who helped launch the Beacon chain. Him and I did a similar NFT around the people who worked on 1559. And so we tried to think like, what's a more general version of that? And at the time, there were all these Gitcoin rounds as well. I don't think Optimism RPGF had quite started. They maybe had the first round, but it was quite small. And then we saw in things like Gitcoin, the problem was like people would say put Geth, but not know that there's like 9 other clients. Or they would put, Geth and Prism, but then all the other clients would get nothing. And then you have people who also work on Ethereum who like maybe don't work for a client team, like say, the testing team or the DevOps. And like, the testing maintainers don't have like a fancy Gitcoin profile, and people on Twitter haven't heard of them, but they make sure that like, Geth and the other clients actually work as intended. And so the idea came for Protocol Guild, and it was to say like, can we take all of those people and just put them together in a list on chain so that when somebody wants to donate to the protocol, they don't have to do the work of figuring out what even are the clients? Should I give more to Geth or more to Nethermind or to Prism? Is there anyone I'm missing? And all of that. And I think the other thing as well at the time is you start to see a couple projects trying to reward those folks in like their airdrops. I remember Element Finance was one of the first who did. They like had all these GitHub repositories of like, again, the people that worked on Geth, on EIPs and stuff, and included them. And I remember looking at that and be like, man, this is so much work for them to build. It's like, not their core product. They have to go and scan and look at these repos and be like, is this a good one, a bad one? And so the idea with Protocol Guild is like, let's just abstract all of this away, have like a single ETH address that people can send funds to, and trust that like it is going to all the core devs. So how Protocol Guild works now is there's effectively 2 main contracts. There's a vesting contract and a split. So by default, all the funds that get sent to Protocol Guild vest over time. So if a project wants to send money, they're not only rewarding like the core devs that are here today, but they're rewarding all the people that are going to show up in the future. And then we have the split contract, which has all of the individuals who contribute to the protocol who've chosen to be in Protocol Guild. Obviously, we don't like force it on anyone. People can like not join for whatever reason, but we have the vast majority of them in Protocol Guild today. And then the split is simply based on the amount of time people have worked on the protocol. We use the square root of the number of months. So it's a pretty straightforward function. And this sort of disproportionately rewards people in like the middle of the pack. So like when people start working on Ethereum, they tend to be super excited and not like move to DeFi quite yet. If people have been working on this stuff for like 5-10 years, it tends to be another reason than just financial that keeps them around. So like rewarding like the sort of mid-level people who've been here for, I don't know, like 2 to 4 or 5 years. That's sort of what Protocol Guild is skewed towards with that function. And the other thing that's really nice is the money goes directly to the people. It doesn't go to the organizations. So for example, Consensus, where I used to work, funds Besu and Teku. But if you're sending money to Consensus, are you confident that like that money actually flows through the engineer that's working on Teku? Whereas in Protocol Guild, it is that person that gets the funds directly. And even if they were to leave, Consensus or another client team and keep working on the protocol independently, they'd still be eligible for Protocol Guild. So that was another thing where it feels like existing grant programs, including the ones from the Ethereum Foundation, have a much easier time targeting organizations, but a much harder time targeting like the actual end people. So Protocol Guild can really complement that, where, it offers a way to directly fund all of these contributors. And so you mentioned RPGF. This is something that's like quite interesting that we've seen is Protocol Guild has been like a really large recipient in the past 2 rounds, but so have like the client teams like entities, which is really neat to see the community sort of decide, what's the fair split between that. Because, these companies are useful, right? Like if a company like Nethermind, they need to hire HR people and marketing people and whatever, you still want to like pay the bills for that. But Protocol Guild doesn't do that. Protocol Guild literally just focuses on the engineers or researchers. And yeah, in RPGF, you've seen like both sides sort of be rewarded by optimism. And that's been really cool to see. So yeah, TLDR's Protocol Guild is just an on-chain list of all the contributors to Ethereum that's weighted by time and where the funds to invest automatically. So any assets can be sent and you don't have to worry about like curating the list as it sort of gets self-created over time.
Yeah, I think it's exciting and interesting to me to see so many different parts of the community recognizing the importance of these contributors and wanting to fund their work. It's something that I feel like in the very early days of Ethereum would have been the hope of someone like Vitalik, and ultimately very organically seems like it bubbled up over the years.
Yeah, no, it's been great to see. And it's been great to see like not only the funders, but also the core developers and the people just working towards like setting this thing up. It's really an exciting project.
I actually last week saw you on a call for something called Summer of Protocols. Could you give us like a high level on what that is?
Yes. So this is like the most speculative thing I work on right now. And the idea is to try and better understand protocols as a class or like a domain rather than just about Ethereum specifically. And maybe the background there is, so I work on the Ethereum protocol, and sometimes I ask myself, like, are we like stewarding this thing right? Like, is this like more than just, did this call go well or wrong? It's like, is the overall direction that we're taking around managing the Ethereum protocol, both as like me running these calls, as the EF, as like a community, like, are we doing the right thing or are we like going in a completely wrong direction? And this is like a hard question. So a few years ago now, I reached out to someone called Venkatesh Rao, who's the author of Ribbon Farm and the Breaking Smart series. And he's basically a tech consultant and blogger and probably the person who has the most knowledge across the most different areas of tech and is most comfortable in like weird problems that I could think of. And he started writing about Ethereum a bit at the time. So I reached out to him for like one-on-one consulting. And I was like, I work on this thing. I don't know how to even think about it, right? Like how to even like, should we compare it to like a tech platform? Should we compare it to like a country? Like how should we like build a governance around it? And so we started talking about this for a while, realized that it was like a way too narrow scope. And so Venkat came on to work with the EF for a few months to help us think about this. And again, even within the EF, it felt like far too narrow. Like even the questions we're asking weren't even right. So we had the idea with the EF last summer of funding a group of like 30-ish researchers from a bunch of different domains to look at protocols across all of their domains and try and see, are there like insights or things that we can learn that apply, not just to like crypto blockchain protocols, but, things that come of like healthcare protocols or like architecture protocols that also apply on what we work on. And not only would this be useful to Ethereum because we get to solve our problems, but we might be able to like build this discipline or this like set of, I don't know, mental models around protocols as a first class thing. So that's what we call Summer of Protocols. We've just started publishing the research that came out of last summer. So if you go to summerprotocols.com, you can see all of the research is online. And we had people, working on like cities, working on safety protocols in workplaces, working on a bunch of different social protocols, or even working on things like, the death of protocols, like how the protocols die, and are there better or worse ways for protocols to like fade out? And are there ways that you can like design their death? If you're aware that, they might eventually die, can you do things today to like make it less worse in the future? So there are all these things that like aren't directly applicable to Ethereum, but help us think about the domain a bit better. So we have the research coming out now, and we'll be running another cohort of this based on all the stuff that came out this summer as well.
I'm curious what you think the spiciest takeaway you've seen so far out of Summer of Protocols is.
I'm not sure if it's the spiciest, but the one that like sort of is seared in my mind now is that it's much easier to define a bad protocol than a good one, because good protocols just like fade into the background. So if I tell you, HTTP is like a good protocol, you don't really have an emotional reaction to that. If I tell you like the TSA is a bad security protocol, like immediately you get like a gut feeling and you're able to like get an intuition for like what are all the things that make the TSA a bad protocol. And this is like a much more useful way to think about protocol design in a way, because if you're thinking of like, okay, what's like a really good protocol, it's going to end up sounding quite boring and you're not sure that you got it right. But then if you like flip it and think, okay, how would this be like, what would the worst version of this protocol look like? It actually gives you the same criteria on which to evaluate it, but it's like instead of aiming for a 10 out of 10, you're aiming for like a 0 out of 10. Like if we don't do all these things wrong, yeah, the protocol is probably all right. So that was like a huge one. I think another thing that maybe like increased my confidence that there's just something here beyond random sort of blockchain explorations is we had this guy Timber working on workplace safety protocols. And I remember reading his essay for the first time and thinking this is just the same as like smart contract development, even though he's talking about like the evolution of safety standards for like mining work in the 1800s. And the fact that like these two things are like so different, but had all of these similar takeaways, yeah, was pretty powerful for me. So I'd say those are the two that I don't keep thinking about over and over. Yeah.
Yeah, I love that. I'm excited to dive in. I was super excited to see the EF supporting this kind of research, especially because I feel like it really, to your point, looks at like this intersection of how the technology that we're building is actually understood by and sort of used by people and how we relate to it. So very excited to dive more into that.
I've got one final spicy question. This was like semi joked about on crypto Twitter, semi serious convo, like brainstorm. Essentially, like there's a big conversation about client diversity and like how do we overcome the fact that Geth has such a high percentage. There's this like huge disincentive now being the supermajority client. You can lose 100% of your staked ETH if something goes wrong, but we're still seeing like so much usage. And so I think the idea came up of like, okay, so what if we just decided that the core devs decided we're not going to ship a hard fork until there is no supermajority or like a certain threshold is met? How does that idea cross you? Is that silly? Is that absurd?
Yeah, so there's two different angles on that question, I think. The first is just the idea of like timing hard forks based on external things. I am super against that. It is already so long to ship hard forks. People complain all the time that we're too slow to ship stuff. So removing any external dependency, I think, is quite healthy. So yeah, I would not tie hard forks to anything we don't have to. And then like more fundamentally, like can we do something to incentivize or disincentivize people using Geth or using another client? The thing that's hard there is the chain doesn't know which client to use. The peer-to-peer network gives you some data that is like roughly accurate on like a real-time basis. But part of the reason why the data is accurate is because there's no incentive to game it. It's super trivial. If you wanted to make it look like, there's 10 times more Nethermind nodes than there are today, you can just, hook them all up to the same database and, or even just change, a bunch of your flags to make it seem like your Geth node is actually running Nethermind. So as soon as like you add any sort of incentive or disincentive around like signaling what type of nodes you run, then you're effectively just going to make the data horrible. And we'll go from like Geth is 80% of the chain and it's bad to we think Geth is still 80%, but we can't even tell because the data is so like low signal. That said, there are some like occasional times when we can tell. So like, Nethermind had a consensus issue a week or two ago now. And you can tell exactly which validators went offline during that consensus issue. So that shows you like with relatively high guarantee that like those validators were using Nethermind. So if you were like designing an airdrop or something like that and wanted to incentivize solo stakers, that's the type of thing that like you could use as a one-off, anecdotal data. And you sort of know it was true because like, the bug happened then, those validators went offline then. So the correlation is pretty strong. And like short of introducing random bugs in clients and saying, Besu's going to add something that makes it go offline, at this random time. which I don't think we should do, just to be 100% clear. You just can't really get that data. So I think, the way for more client diversity is just for different clients to optimize for different things and like get users based on the quality of their features. And I say this as someone who worked on a minority client for like 2.5 years. Today, Aragon is the lightest weight archive node, and a bunch of people use it for that purpose because it's just much more efficient than other clients. I think Nethermind gives you probably the smallest execution layer client. So if you're concerned about disk space and stuff like that, like it is the best option. And then similarly, Reth is working on a ton of modularity and sort of use cases for that and around block building, which I think will appeal to like a bunch of users. I think that's probably the more healthy way to go about it, where it's like you do have different clients which specialize in different things. And I think at this point, all of the clients are pretty high quality. When I worked on Besu, we were working on the client in like 2018, and Geth had been live for like 3-4 years already. We had like a ton of catch up to do. And I think this is why you saw, especially on the execution layer, things take time to catch up. Like Aragon, Besu, and Geth were all roughly started around the same time. And then Parity sort of got abandoned over the years as well, which was the other sort of older client. But now I think we've seen that like, yeah, we have all these teams that have, pretty mature clients that are like as stable and offer different functionality. So yeah, hopefully over time, it means people sort of start switching. And then I think for larger operators, like you hinted at, it does become a question of like safety or reliance, where like if they have everything relying on Geth or on some other like single client and something goes wrong there, they've compromised their assets or their customers' assets based on that. And, that's not a good spot to be in. And at the very least, I mean, if I was running an exchange or a staking service, even if I was using Geth, I'd want to be in a spot where I could move to like another client in, minutes if I had to. And I think this is something there as well, where like beyond just like switching as like your default, like having all these operators build fail safes and even do things like run 2 different clients locally and, compare the outputs before they propose a block or a test of a block or stuff like that. I think those things are going to be demanded more and more by users. And maybe it's just a question of seeing like one large staking service or exchange or whatever have an issue because they were just running a single client. And then everybody else will be like, why are you doing this? And, like, why aren't my funds as safe as they could be? So yeah, I there is unfortunately not a silver bullet, but I think we're in a spot where like it is trending in the right direction, even though we're starting from a pretty poor baseline.
It's a good answer. Thank you.
Yeah.
Seems like client diversity is always a moving target, ultimately.
Yeah, although I think on the consensus layer, like things are pretty good. I haven't checked the numbers super recently, but yeah, I think things are quite good there. And as well, Prism was the first client to start, even though it was like months rather than years before the other ones. And so when the beacon chain went live, people just like knew about Prism more, but the gap with other clients was much, much smaller. And now it's like, there is like a pretty healthy distribution on the consensus layer side. So I'm optimistic we'll get to the same level on the execution layer. But yeah, it's normal for these things to take time and for people to not want to like be the first mover and changing stuff there.
Totally. Well, Tim, it was so wonderful to have you on the pod. Where can people learn more about the wonderful work that you're doing and all of the things happening in Ethereum protocol land?
Yeah, 2 places. So Farcaster, I'm at Tim on Farcaster, and then I'm at Tim Beiko on Twitter as well. So those are the 2 places I post the most and tend to post stuff a bit earlier and less polished on Farcaster before it goes to Twitter. So yeah, would encourage you to check that out if you haven't already.
I love it. Cool. Well, thank you so much for coming on the pod. We will link all of the things that we talked about in the show notes. But yeah, this was such a wonderful conversation.
Yeah, thank you both for having me. This was great.
Thank you, Tim.